So last time we talked about Kramer's rule, and I said it's one of my least favorite solving techniques. This is row-echelon form. This is probably my favorite solving technique, even though, to be honest, if I was solving a system, I probably wouldn't solve using this technique. But it's just so cool that I can't pass up showing it to you guys. So the real mathletes out there, you'll probably like this. Some of you will hate it. But just for the record, this is not, you don't have to use this method. I'm not forcing you to do this method on the test. You don't have to choose this method. If anybody wants to do this method, they can opt in. So the first thing I want to talk about is something called an augmented matrix. An augmented matrix is, remember how we made those matrices? We call it the coefficient matrix. Well, an augmented matrix, we did a coefficient matrix and a constant matrix. An augmented matrix is when you put those two together. So I'm going to have my coefficients, 1, 1, 1, and a constant of 2. My coefficients, 2, -1, 3, and a constant of -1. -1, 2, -1, and a constant of 4. This is what we call an augmented matrix, and usually we put a line between these to indicate where the equal sign is. I think that's supposed to be a dashed line. I never draw mine dashed. I always draw it solid. So let's have you try to write an augmented matrix for the second system. Hopefully you notice that you were missing some stuff. So it would be 1, 3, 0, 9, because that didn't have a z term. This doesn't have an x. It does have a y. It does have a z. And it has an x. It doesn't have a y, and it does have a z. All right, so there's augmented matrices. To solve systems using row-echelon form, the first thing we do is we write our system in an augmented matrix. So let's take our system and convert it into an augmented matrix. That would be 1, -2, 3, 9, -1, 3, 1, -2, 2, -5, 5, and 17. So there are a couple rules that you can use when you're solving systems using row-echelon form. So the couple of rules are, number 1, you can add any two rows together. And when I say add, I could also say subtract if you wanted to. Usually I multiply by a negative and then add. So you can add any two rows together. Number 2, you can multiply any row by a constant. And then number 3, you can interchange any two rows. So that means that if you've got a row in the first row and you want it to be in the third row, go for it. So we're trying to set up, what we're trying to get is we want our matrix, our augmented matrix, to look like this. 1, then I don't care, and I don't care. Those could be any sort of numbers. Then a 0 and a 1, and then I don't care, and I don't care what these numbers are. Then a 0, and a 1, and I don't care what this number is. This is what we're trying to get our augmented matrix to look like. So if you look at what we have here, I'm trying to get it to look like this. So that means I have a 1 in the first row. The second row has a 0 and then a 1. And the third row has a 0 and a 0 and a 1. And these numbers can be any numbers that you want. It doesn't matter. So let's look at the augmented matrix that we have right now. Do we like it as it is? Yeah, does my first row have a 1 in it? Basically, that's the only question I'm asking. Yes, it does. So I'm going to keep that. 1, -2, 3, 9, -1, 3, 1, -2, 2, -5, 5, and 17. Now, what I usually do is I always start my next matrix, and I keep the things that I'm happy with in my new matrix. So my new matrix, I like -1, -2, 3, and 9. Do I like the second row? No. The second row is supposed to have a 0, and I have a -1. So I'm going to take, remember, you can add any two rows together, or you could multiply, or you could interchange rows. So do I have a 0? No. Do I want to multiply by 0? Well, you could, but it'd make it a 0, but it'd make everything a 0. Remember, the second number is supposed to be a 1. Could I add any two rows together and cancel out that first term? Yes, and that's the move that I'm going to do here. So I'm going to take row 1, and I'm going to add it to row 2. I would get a 0, a 1, a 4, and a 7. That's a good thing. 0, 1, 4, and 7. That's a good thing because now this second row has a 0 and then a 1. Now, this third row I didn't mess with, so I'm just going to carry it over into my new matrix. Now I'm going to start another matrix. What are the things that I like? I like row 1. I like row 2 because they look like the format that I'm trying to get. What I don't like is row 3, so I'm going to have to do some work on row 3. Now, if I add, right now, if I try to add any of the rows together, that 2 is not going to cancel out. So what I can do is I can take row 1, I can multiply that by a -2 to try to turn this thing into a 0. Now, look, I want both of them to be 0, but for right now, I'm just going to worry about making this first thing 0. So let's take row 1 and multiply it by, remember, I can multiply any row by a constant, and then I can add those rows together. So I'm going to take row 1, I'm going to times it by -2, so that would be -2, +4, -6, and -18. And I'm going to take row 3, and now I can add these two together. I get -2 plus 2 is 0. 4 minus 5 is -1. -6 minus 5 is -1. -18 and 17 is -1. All right. So I like this better. This is a row 3 that I'm trying to build. I like it because it has a 0 in the first spot, but it's supposed to have a 0 in the second spot. So that means I can take any other row, and I can work with that row to try to cancel out now the next spot. Well, you have to be careful here. If you pick anything besides a row that has a 0 at the beginning, you're going to be in trouble because then this will turn into something besides 0. So your hands are pretty tied here. You have to use this row. Now in this one, I made it pretty easy that this is going to automatically cancel with that. So I'm going to take row 2. I'm going to add it to my new row 3, and that's going to become my new row 3. So 0, 0, -1, 1, -1, 4, -1, 7. Okay, so you might say, all right, we're kind of in good shape. We have a 0, but this is supposed to be a 1. I have a 0, but that's a 3. So what can I do to this line? Remember, you can multiply any row, but you could also divide any row. Multiply and divide mean the same thing. So I'm going to actually add that for next year. Divide and subtract. You can add or subtract or mult or divide. So I'm going to take this and now I'm going to divide it by 3. What's 0 divided by 3? 0. What's 0 divided by 3? 0. What's 3 divided by 3? 1. And what's 6 divided by 3? 2. And all of a sudden, I now have my augmented matrix in this setup that we call row-echelon form. Why does that help us? Why does that matter? Because remember, these initially were the coefficients of x, y, or z. So this row right here says that you have 0 x's, you have 0 y's, and you have 1 z. And remember that that bar represented an equal sign, and that equaled 2. So what have we just figured out? we've just figured out that z has to be 2. Now, if I know what z is, I can back substitute it into this line, because this line says that there is no x, there is 1y plus 4 z's equals 7. So we know that z now is 2, so I can back substitute y plus 4 times 2 equals 7. 4 times 2 is 8. Subtract that across, I get y equals -1. So now I know what x is. Sorry, I know what z is. I know what y is. Don't forget, this line is x, y, and z. So now I have a whole equation. 1x minus 2 y's, which we just figured out was -1, plus 3 z's, which we just figured out before that was 2, is equal to 9. So I would get x plus 2 plus 6 equals 9, which means that's 8, so x equals 1. And now I can take that all together and get one solution, 1 comma, -1 comma 2 x, y, and z. All right, I doubt that this feels great. And usually these notes, you got to go through the second example and you feel a little bit better. And then by the time you get to the third example, you can kind of do it on your own. So let's remember this row echelon form, 1, 0, 1, 0, 0, 1, and try 1 on the back. So I'm going to start off by trying to identify augmented form, augmented matrix. So that's 2, -1, 1, -4, 1, 2, 1, -4, 1, 3, -1, -7. All right, are we happy with, I'm going to start my new matrix. Are we happy with row 1? No, because it's supposed to be a 1. It's got a 2 in front. So how can I make it happy? I can swap 1 and 2 around. So I'm going to take row 1 and row 2, and I'm going to trade them. 1, 2, 1, -4. 2, -1, 1, -4, and 1, 3, -1, -7. Okay, now are we happy with row 1? Yes. So I'm going to continue row 1, 1, 2, 1, -4, into my new matrix. Are we happy with row 2? No. So I'm going to have to do some work on row 2. So I want this to be a 0. I can't just directly cancel, but I can multiply row 1 by a negative. That would end up canceling it out. So I'm going to take row 1, I'm going to times it by a -2. So row 1 times -2 would be -2, -4, -2, +8, and then row 2, 2, -1, 1, -4. I can add these up. That would be 0. That would be -5. That would be -1, and then that would be 4. So there's two ways to go from here. If you want to, gosh, why didn't I go after 1 and 3? So what you could do here is you could divide everything by -5. Now you would get some decimals. That's okay. Don't be afraid of decimals. The answers will still work out. You just might have to do a little bit more work along the way. But yeah, let's do it with decimals. Let's leave the decimals in there. So remember, this is supposed to be a 0 and then a 1. So I'm going to divide everything by -5. So that would be 0. -5 divided by -5 is 1. -1 divided by -5 is 0.2. 4 divided by -5 is -0.8. I didn't mess with the last row. 1, 3, -1, -7. Okay, what do we like? We like row 1. 1, 2, 1, -4. We don't love row 2, but at least it's got a 0 and a 1 out front, so I can deal with the decimals. And I don't like row 3, so we're going to have to do some work on row 3. So we first need to turn row 3 into a 0 out front. So this time I'm going to take row 1 and row 2, and I'm going to use those. So I'm going to take row 1, multiply it by a negative. I'm going to take row 3, I'm going to leave it. That adds up to 0. That adds up to 1. That adds up to -2. That adds up to -3. Now, I've got to pick one that I can use that will kill off this term. So I've already got that in row 2. I've got a 0 and a 1. I want to leave the 0 out front, but I want this to become a -1. So I'm going to multiply that by a negative. So we would get 0, -1, -0.2, and +0.8. Okay, fingers crossed that this is going to work out. I'm going to go back to the other color so that I can keep in mind that this is going to be the green equation. 0 and 0 is 0. 1 and -1 is 0. -2 and -0.2 is -2.2. -3 and 0.8. So -3 plus a 0.8 ends up being -2.2. Now, I want this to be a 0, and a 1. So I would have to divide everything by -2.2, and that's fine. I would get 0, 0, 1, and 1. Because when I divide by -2.2, that's 0, that's 0, that's 1, that's 1. So what did they tell us? What have we figured out? We have now figured out that z is equal to 1. Then I can back substitute that into the equation before. So that's 1y plus 0.2 times 1 equals -0.8. So what's that? That's y plus 0.2 equals -0.8. Subtract, we get y equals -1. And then to finally find out what x would be, let's go to this one. There would be 1x plus 2 times, we figured out that y was -1, plus 1. We figured out that z was also 1, and that equaled -4. So this is x, that's -2, that's 1 equals -4, that's -1. So I'd have to add, so x minus 1 equals -4, add that across, x equals -3. So our solution is -3, -1, and 1. Now, is this faster than typing it into your calculator? Of course not. No, of course not. But I just think it's kind of cool. It's just something I have to show you, just because I mean, I don't have to. I want to, because I think it's just a cool sort of a solving technique for people that like to see things a little bit different than the boring old whatever is easiest. All right, let's see if you can handle this last one. So I'm going to encourage you to pause. You can kind of start and pause and start and pause as you're going through, but you should be able to now at least get a pretty good sense of how to solve this. All right, so I'm first going to set up my matrix, my augmented matrix. Actually, you know what? I'm going to save myself a step here. I already know that my augmented matrix isn't going to have a 1 in the first row unless I switch these two. So I'm going to do that right off the bat. 1, 3, 4, 7, 2, 7, 5, 10, 3, 10, 4, 27. So my first move was to switch row 1 and row 3. Then you always start a new matrix. Are you happy with anything in matrix 1? Yes, I'm happy with row 1. 1, 3, 4, 7. Am I happy with row 2? No, I'm going to have to do some work on row 2. So I can figure out row 2 by taking row 1 and multiplying it by a negative 2. So that would be negative 2, negative 6, negative 8, negative 14, 2, 7, 5, and 10. That would add up to be 0, 1, negative 3, and negative 4. Am I happy with row 3? No, so I'm just going to carry that one over. 3, 10, 4, 27. Start your new matrix. I like row 1. I like row 2. I think I'm going to keep those colors. I got to do some work on row 3. So what could I use? I could use row 1 and times it by a negative. So I'm going to take row 1. I'm going to times it by a negative 3. That'd be negative 3, negative 9, negative 12, negative 21. 3, 10, 4, 27. That adds up to 0. That's 1. That's negative 8. And that's 6. Okay, now I need this to also be a 0. So I'm going to take the green one and I'm going to multiply that by negative 1. So that would be 0, negative 1, positive 3, positive 4, which I can then add together. And we would get 0, 0, negative 5, and 10. Oh, that makes my math voice so happy because I can then divide this one by negative 5 and I don't get any decimals. So 0, 0, 1, negative 2. Okay, so from here you could back substitute again. And that means z equals negative 2. Plug it in, plug it in. I'm going to show you another trick. This is called reduced row echelon form. Reduced row echelon form looks like this. 1, 0, 0, and then a number. 0, 1, 0, and then a number. 0, 0, 1, and then a number. So in this case, I like the bottom row. 0, 0, 1, negative 2. I'm going to do some work on the second row. So the second row, I'm going to take 0, 1, negative 3, and negative 4. And this time I want to cancel out the negative 3. That I could take the pink row and I could times it by positive 3. 0, 0, 3, negative 6. And when I add those two together, I would get 0, 1, 0, negative 10. 0, 1, 0, negative 10. And then as I look at the top row, I don't like the 1. Sorry, I do like the 1, but I don't like the 3, and I don't like the 4. So I'm going to take that top row, 1, 3, 4, and 7. I'm going to kill off the 4 using the pink row. So I'm going to times the pink row by negative 4. 0, 0, negative 4, 8. I also don't like the 3. I'm going to kill that with the green row. Multiply that by negative 3, 0, negative 3, 0, 30. And I can add these all together. 1, 0, 0, that's 15, and 30 is 45. And I get 1, 0, 0, 45. I wish I would have left this as pink. 0, 0, 1, negative 2. Now look at what we've got. I don't know if you did it the other way, or I assume you did it the other way. What did you get for your solution? 45, negative 10, and negative 2? That's because I now turn this into reduced. This is called reduced row echelon form. And that's where I have only ones as 1x and 1y and 1z. So each one of these is their own solution. So my overall answer would be 45, negative 10, and negative 2. Amazing, right? I don't know. I think it's fun. I think it's cool. Like I said, you do not have to do this. This is an optional. If you want to use this method on the test, you can use it, but you don't have to. All right, go get them. Good luck.